you guys are just going to place faith in this, that this is correct.
No, the
What was it?
X is 1.
Did I make a mistake?
9.
Well, I agree with the X one, it's 9/7.
Hold on.
No, it's 9/7. It's definitely 9/7.
I heard that. Calculator?
It's fractions.
Actually, I'm being silly, guys. I do think it's correct, but I'm just double checking.
It is. It is.
Right. Okay. Never mind.
14 minus 5. As long as you're happy.
Never mind. I need more coffee in my system. That's why I'm tripping out on that. Yeah, okay.
That is not a line. It's not a line because when you take a peek at these expressions here and here are the components. They're not linear expressions like they are with my lines. I do, however, think this is an example of vector valued function. And relative to my introduction the other day with vector valued functions, what do you think this one right here looks like?
Gorgeous.
Yes, it does.
Sinusoidal vector, like a wave.
Is it? When you say wave,
It's like a
is that the surface?
It's a three-dimensional wave.
So it's t squared and then...
But it looks like it's parabolic also.
Cosine thing, and the z component looks like a... I'm going to need to see a schematic of this. I can't picture it.
Schematic. Linda?
Some sort of spiral.
I heard you use the word spring. So don't you guys think if I allow the x values all to be equal to 0, I'm just in the y-z coordinate plane, and it's spinning around on a
On a circle.
I can't hear you.
On a circle.
Spiral?
He just sort of ellipse. Oh, but shoot, I'm not in the xy coordinate plane. As I'm tracing out this ellipse, I am in English, I am
Getting bigger,
going out on the x-axis how?
exponentially larger.
Positively, but in an increasing fashion, non-linear. So sort of like the springs being pulled in a quadratic fashion. So unlike the helix I gave you guys the other day, I guess I'm not increasing in one of the axes direction in a very linear fashion. I'm increasing in a quadratic fashion.
It's more like a spiral, parabola shape.
So it'd be like a spring, pulled along the x-axis, but spring is actually increasing in length as I go out with t.
So,
It's like a spiral. But
is there actually a name for that shape, or is it just
No, that's why I have to use
an
so many words
increasing
to
spring?
describe it.
Alright.
On the test, are you going to ask us, like, to describe the object generated by I don't want to say, like, dude, that's
Yeah.
super easy.
Emphatically, particularly when it comes to surfaces and free space. You bet.
Can't see that.
Can we describe it just by graphing it?
You know what a lot of people do? They have a difficult time describing a surface in free space.
Yeah.
This is something you and I will do sometimes. Well, take a look at what it looks like when you take two-dimensional cross-sectional slices. Where it intersects with planes.
Okay.
Sometimes I'll take multiple cross-sectional slices parallel to each other so I can get a picture, get an idea of what the picture is. For example, if I were to take, here's the x-axis. This is beyond the scope of this section, you guys. But if I had a three-dimensional parabola called a paraboloid, I mean, the cross-sectional slices are nothing more than...
Wait, in which direction? In which direction?
Well,
They're
I
ellipses.
meant parallel to the xy coordinate.
Okay, in that there are ellipses, yes.
Yeah, I agree. They're just going to be ellipses. Well, it could be circles, but generally ellipses. And therefore, when you guys take a peek at the equation of this particular surface, that is the equation of that surface. So when you fix z, say it's equal to 7, clearly this is just a parabola. Excuse me. Clearly this is the equation of a
No, wait. No, it's just a circle.
an ellipse. It's a cross-sectional slice of this three-dimensional surface called a paraboloid, where the cross-section is an ellipse because when I allow z to be a fixed constant, like 7, that's a z and that's a 7. When I allow z to be a fixed constant, I get the equation of the piece of cake. So a lot of times we do that. We cheat and look at correct cross-sectional slices if it's difficult to generate the corresponding image just like that in free space.
But in this chapter test, are you going to have us do that?
Maybe some basic ones like lines. By the way, you guys, I don't give chapter tests. I just give a test when I say I give a test. Covering all the material.
But is it fixed on the dates that you gave us at the beginning of the term?
I don't know. Generally it is, but when I get a collection of students who complain to me, saying, oh, most of us are in Physics 4C, and we got an exam the same day. I mean, I'll change it if it's just pressure from you guys that you don't like that date. That makes sense.
Oh, okay. Because I want to say 160.
That sounds right. It should be right on the 16th.
It's a week from this Friday.
Friday, the 20th.
Week from this Friday.
It's 20th, okay.
Yeah. So.
Hey, where do you get those dates?
Uh-huh.
Yeah, September 20th is our first.
On his website.
Yeah, in the syllabus, is that
In the
correct?
syllabus.
I also made sure the examiner's class, for those of you taking 33, are on a different week than the 33's exam.
Are you going to, like, during the test, I hope you're not gonna make it like stupid long, because we only have an hour worth of class. But let's say theoretically you do, are you gonna give us a little bit of bonus time at the end to be able to actually complete the test?
I don't know. Is there anybody in this room after us on Friday?
It's Friday.
I gave the answers. Hi, Chuck. There's no meeting here after us.
Oh, we got plenty of time.
Is there anybody in this room, due to work, family, or classes? Can't stay late.
On Friday?
Maybe a day by day.
I'll ask you as we get closer.
I have work on Saturdays after.
Oh, do you really?
Yeah, math.
What about form? You still in math then? Oh, jeez.
But they'd understand if you had to stay for a
Yeah,
test.
you did, but.
Yeah.
Yeah, they're kind of friendly in the math. Something.
Yeah.
Well, everybody, if I can represent a vector value function in this fashion, where I got components that themselves are not constants. Well, you guys, again, this really is an example of vector value function, even though it might feel like.
What's up with that?
I have no idea what's up with that. It's Monday.
All right.
But you guys, if this is how I'm going to think about a vector value function, tracing curve in 3 space, why not suggest? Does it take the limit of it? Is as easy as component-wise taking limits. And to differentiate is as easy as component-wise differentiation. And finally, to tell you guys how to actually integrate a vector valued function, sheepers, I'm on a roll. You can see where I'm going with this. Is just yet again component-wise integration. So, what would you get here? You guys are
You'd
doing
have
math 3, aren't you?
pi over 2.
I don't remember this.
What? You don't mean that.
Cosine hyperbolic. Jeez.
Where's my lookup table?
I'm not sure about the cosine hyperbolic. I don't remember that. In the final one, though, you'd have a L'Hopital situation, wouldn't you?
I'm nervous about the last one. You said L'Hopital because technically speaking,
Well, it's an
I get
infinity
it.
over
Infinity to
infinity
that.
raised to the infinity, right?
don't you get a 1 to the infinity power?
Huh?
Don't you get a 1 to the infinity power? So when you get a 1 to the infinity power, it's not an indeterminate form for which L'Hopital's rule
You
applies.
do? How do you
It
get
is
a
an
1 to
indeterminate form.
infinity? Because the t would just be in the numerator would just be 1, right? Or would just be infinity, right? If you took the limit going to infinity.
What's the inverse cosine, inverse hyperbolic cosine of 1?
Oh,
Anybody?
I have a question on the practice test. Are you gonna give us one?
Practice tests?
Yeah. Or practice.
maybe post examples from previous tests.
Oh,
Yeah.
okay. If I do that, it's for the sole purpose of you see what kind of expands. I would hate to see you use it as dying.
Why wouldn't you just like? Yeah, but can you put the solutions to it too, so we can like study from it?
If I get to the
Okay.
second, how do you take the limit of that?
Well, that just goes. Well, I mean, if you have 1 over infinity, that just goes to 0. But I just don't know. I don't know what the cosine hyperbolic looks like. So I can't graphically analyze it without.
That's hyperbolic.
Can you draw it on a graph?
Yeah, but I'm hoping you guys can actually generate what it looks like, or what it looks like out there. Use it what? Oh, come on, do you guys remember this, yes or no?
No.
Then if you don't remember, no big deal, you just regenerate it.
Okay.
Do you remember this?
E to the x minus 9. I don't have it memorized.
Thank you. That being the case, I can sometimes write it this way. So you guys, what's your favorite math? What's your favorite math course?
D.
Math D.
Math D. So using your Math D skills, I can do Math D. How do you find the inverse function?
Plug Y's in for X.
Interchange X's and Y's, I heard that. And then what?
Solve for.
Solve for Y in terms of X.
But that's so
That's
easy.
infinity over 2.
No, it's not.
You take the limit.
Just bring that one over. You're gonna have 2x e to the y, e to the 2y minus 1, or plus 1.
I don't get it.
That is the ugliest way you can possibly do that.
What? That's beautiful.
So
Idiots. I mean, you can. All you're gonna do is you're just gonna complete the square. But
how do you generate e to the x plus e to the negative x over 2 from cosine hyperbolic?
you have to memorize it.
Definitely.
I mean, just memorizing it. That's it.
Well, I hate to say memorize. I mean, you've seen this so many times.
I know, but it'd be nice if we had an actual lecture with homework on hyperbolics.
All right, I promise I'll get that.
Okay.
I'll do it. Eric?
Oh, near? Oh, I was just gonna say it's just completing the square. So just take the 1 over, and then you got.
True. Or you can use the quadratic formula. That's entirely up to you.
Yeah.
And so I maintain that what's sitting in front of me, shoot, is merely quadratic in the red beast. Would you guys agree?
It's not.
Yes? No?
Yeah.
No?
Yeah. It's.
So one yes.
And then all you do is as soon as you get that, you
That's
take.
just 1 over e to the y, isn't it? So multiply both sides by e to the y, that's where I get this. and then I will just use the quadratic formula. And I maintain what you see in red is nothing more than cheapers. How did that go? That was a negative b plus or minus the square root of b squared, which is this, minus 4ac, which is this, all over 2a. Or shall we say, e to the y, oh, I'm running out of room. E to the y is nothing more than x plus or minus the square root of 4x squared minus 4. Okay, I've made a mistake. Technically speaking, when it comes to the hyperbolic cosine function, you know what it looks like.
It's always positive, correct? So you
Sure.
take out the negative value, and there's also an ln in there.
Well, we'll get there. We'll get there.
So-
Did you have the 4 inside the radical?
What was that? I'm sorry.
The 4s on the inside of the radical there?
Basically, he's saying you should factor out the
Don't you
fourth
see them
position.
cancel? They really do cancel. Can't you see it?
Well, yeah, but you didn't. Sorry.
So graphically, what does the cosine hyperbolic look like?
X-axis, y-axis.
Okay.
It's in the appendix in the back of the book.
Are there any asymptotes?
All right.
Are there any asymptotes?
Are there any asymptotes? Isn't it going to be? I want to say between the points where the. Oh wow! I totally just drew a blank. Between pi and negative pi, I want to say.
Pi and negative pi.
'Cause that's,
Oh, you're saying there's vertical asymptotes.
are they?
There aren't.
Oh, okay.
Are,
So would the
The hyperbolic cosine curve approaches
Sorry.
the curves e to the negative, or e to the negative x over 2 and e to the x over 2.
So there are two asymptotes. They're just nonlinear. Do you guys see that? Be honest. Okay.
No.
You know me. Do this. Can I play this game? But if x is huge, enormous, would you guys not agree that this term right here is negligible? So I think at extreme values of x, this thing is going to 0. So I think the graph of this beast is getting closer and closer to the graph of that exponential function as x increases without bound. Therefore, y equals 1/2 e to the x is acting as a nonlinear asymptote for this curve at large values of x. However, for very negative values of x, that's going in the other direction, I think this term becomes significant, but this one is going to go to 0 as x decreases outbound. Therefore, y equals what's circled here is going to be another asymptote in the left-hand plane for the graph of this hyperbolic function. Do you agree? Brad,
So
you asked.
would the limit not, like, if it wasn't coming from one side, would it just not exist?
Oh, I can take the limit of this function as x approaches 7.3. I just don't guess it as interesting as one of these underlying curves.
Okay.
And Brad, you asked, what does the graph of the hyperbolic cosine function look like? Well, technically speaking, if x is equal to 0, what do I get?
an imaginary number?
Yeah, it's not a real number. So I think clearly the domain of this function is going to be all real numbers outside of 1, or negative 1. But since I'm going to make the restriction of saying the original curve doesn't have an inverse, it doesn't satisfy the horizontal line test, then let's just take one portion of it, this portion. And if I reflect that through the line y equals x, aren't I going to get this? So when I solve for y down here, by taking the natural log of both sides, I think this is what I'm referring to as the inverse hyperbolic cosine of x.
But because you're doing that as 1 over t, wouldn't that be equal to 0, but there is no answer for 0 there? Oh, over there, with the r bar of t.
I'm sorry, I'm stalling because I have to think about it. You're right. Now that if I take the inverse, if I take the limit as x goes to 1, this ends up being 0, and I made this example up out of thin air. Shoot. Can I change it? Is that better? So now I can take the limit. And by the way, the limit is
Wouldn't you have a,
take the limit.
wouldn't you have like kind of a logarithmic deal going on there, and then you'd have to L'Hopital it?
No.
and then back substitute for the logarithm?
No, isn't it just gonna be 0? Because you factor out a t, and so you have 1.
It's bigger
One-
than 0. It's bigger than 0.
1, wait.
E to that matter.
I don't see it.
You did a -4? How do you go about getting that? Because if you,
Yeah.
I guess in my
Well,
mind,
you just-
what you do is you're gonna factor out a t, so then you're gonna get 1 over 1 plus 4
No,
over
no.
t.
Oh, all right, if you want me to show my work, I will.
You have
If you do it
to
that way, you take,
you have to take the natural log and then L'Hopital what's on the inside, and then back substitute it by taking e to whatever the value is that you got.
but that's so much work.
It doesn't take too long. It's a pretty easy problem, actually. You just differentiate it once.
Do you guys agree? This is indeed an indeterminate form, no tricks. Because as t increases that bound, I think this whole thing goes to 1 to the infinity power. That is an indeterminate form. Unfortunately, not one for which I can apply L'Hopital's rule, because L'Hopital's rule only applies to these indeterminate forms that are infinity over infinity or 0 over 0. However, I was kind of hoping you guys would just recognize this number. Is this true? The limit, as t increases that bound of, I'm going to flip that fraction.
What?
Oh, I can't, can I? I'll flip it twice. And I'll raise.
Or you can do that.
I'm not.
And this is not any more than this.
I'm not sure. That makes sense.
Sorry.
What? Huh?
Is that okay? I'm serious.
I don't get it.
No?
Brad, where did I lose you? From here to here?
Well, yeah, because normally you would massage the equation,
just-
but you just made it worse, it looks like. I mean,
Well, I took a mathematical axe here, split this up into 2 fractions inside the parentheses.
I know,
Oh, okay.
but you've still got it being raised to an exponent in the denominator.
I'll get there, I'll get there.
Okay.
Is that okay?
Don't you need to take some complicated?
What happened?
I need to take one, I'm sorry.
Well, you substitute 4p in for t, well, you didn't do that for the top t, that's the exponent.
Yeah, I did right there, it's a P.
Oh, sorry, I noticed.
I just took the 4
Yeah,
out.
I missed that. Okay, okay.
Come on, you guys, in a roar. Really?
The roar?
Yeah.
Oh, you did that.
What?
Well, don't you recognize the limit of this as t increase that bound is just E?
Yes, yes, I remember that.
E.
Yeah.
All right, don't listen to me, don't listen to me. So can we apply the French technique?
French technique? Oh.
Yeah. Mhm.
L'Hopital's rule? And by the way, this time it legally applies. I think what I ended up getting upstairs, let's see, differentiate log of anything is just 1 over that thing. But I got to multiply by the derivative of the inside. But downstairs, when I differentiate 1 over x, it's the same darn red beast. These two drop out. Now when I evaluate the limit, what do I get?
1 over 1 plus 1 over x.
Just 1.
as it goes to infinity x.
Okay.
Oh, but shoot, you guys, that was a natural log of y. To get y right back, I'm just gonna, I'm gonna exponentiate both sides, and that's just gonna give my y. So when I exponentiate over here, I think we've already proven that this thing goes to one, therefore y goes to e. Piece of cake. Truly?
So what happened to the 4?
What's that? I
Or
just
did
pulled
you,
it out.
did you change the, okay.
I pulled it out. Oh, yeah, down here, Brad, sorry, I was answering the question, what is this
Okay.
limit? And I changed back to x because it's easier.
Okay.
That was painful. I was hoping it wasn't gonna be.
It's like 150 almost exactly. I mean 1250.
Oh my gosh, are we already out of time?
Yeah.
No, we have 1 minute.
Can I ask one more question? I got a better idea. Why don't you guys just write this down and see if you can evaluate it. You guys want to treat this as an extra quiz?
Yes.
What?
Just treat this as an extra quiz. You can give it to me next time.
Just the take home?
Yes.
Are you gonna post it online or should we just write it down?
I was hoping you just write it down. I didn't plan on this, guy, but it just sounds optional.
Extra credit?
Well, not extra credit, but an extra quiz.
Oh, no, I don't bracket. Oh.
Don't moan. Gosh.
It's a quiz, so you have all the time you want to do it.
Well, until Wednesday.
There's quiz,
Yeah, that's 2 days.
quiz 4? Quiz 3? Which, 4?
Yes,
Okay.
Is that one over all that
It is.
stuff for the second thing? Or for the second one?
I don't know yet.
Oh.
I'm getting there.
I hate PF.
Wait, what's that? Is that common?
I didn't realize that, but.
Oh, wow, we got a whole other term there. Wow. Okay.
Is that just less than or equal to? Or
No,
is that-
no,
Oh, no, that's a
that's-
vector, that's a vector, never mind. I'm still in computer science mode.
Come on, I want to think of something fun.
Oh, that's the same one that you gave your Math 31 students.
Yeah. I asked this question Math 31 last week, or the week before.
Yep.
Not one person in the class answered correctly.
Oh, boy.
Well, they are just,
All right, I think I'm happy. That was good. Oh, homework, jeepers. My goodness. You guys, I apologize for keeping this so late. You and I are going to take a peek into section 11.5.
Was this quiz due Wednesday or Friday?
Yes, Wednesday. And you guys, in section 11.5, take a peek at the following. Don't listen to me.
Wait, don't do those.
No, think about it. 9 through 37 has
Oh,
to be
Don't
1
think
point
about it.
two.
It's embarrassing.
Yeah, I wasn't paying attention either.
I wasn't either. You guys, I think I'm happy.
Alright, so we automatically get a bonus 10 on that table.